Hello students, welcome to Power Tutorials. So today we're going to have another live session on parallel circuit connection. So in this video we're going to explain about what is parallel circuit connection, how to find the resistance parameters, that is if two resistors are connected in parallel, how to find those things, how to find the effective resistance, how to find the current, and what are the parameters different and similar to series circuit connection. So in this video we're going to explain about, so all this will be covering in this video. Okay, so let's start. So before going to this video, if you are coming new to my channel, so in my channel I provide videos on 10th class CBSE, as also for few videos on Telangana maths and science subjects as well. So if you're interested to watch those videos, you can check my channel, and every day I'm keeping 2 MCQ questions in my channel community post. So if you're interested to solve MCQ question, you can also refer to that community section, that is post section in my YouTube channel. Okay, so let's start with the content. So I'll just give a small recap out of what we have discussed in the series circuit connection first. So in the series circuit video, I have explained about what is series connection. Like I have mentioned clearly that if the starting and ending of one resistors are connected, then I can simply say the circuit is in a series connection. Same as this is circuit connection, where you can see we have 5 volts as a battery, and this is connected to two resistors which are in series, because the end of one resistor is connected to the start of another resistor. Okay, and also explained about Ohm's law. Ohm's law is where when voltage of any element is proportional to the amount of current passing through it. So simply V is proportional to I, and to remove that proportionality constant we have the parameter which is resistance. So that's why we have to say that Ohm's law is V is equal to Ri. Okay, and then we discuss about like we found the values of resistance, and we also find the amount of current passing through the resistors. We solved few numericals, and we also solved the exercise questions which are there in the textbook. So those we have covered. So now we are going to start with parallel circuit connection. So the simple example of a parallel circuit connection is starting and ending points of elements should be connected. For example, if I say I have two resistors like this, R1, R2, then I will say these two are in parallel. Why? Because this is the starting point of this resistor, this is the starting point of this resistor. Both the starting points are connected and both the ending points are connected. Okay, so simple, not only for resistors, if any elements, if I say like inductors and all will be new to, for example, any element, not only resistor, I can say that element 1, and if I have element 2, and if the starting point of this element and starting point of this element are connected, at the same point ending of this element and the ending of this element are connected. So this I can see these two elements are in parallel. So how about series? I explained last time, this is one resistor and this is another resistor. You can notice that this is one point and this is another point, I mean ending, and this ending is connected to the starting, but the ends are not connected. I mean this start and this end are not connected. Whereas in parallel, both the starting points should be connected and both the ending points should be connected. Okay, so if we in a circuit, if you see that starting points and ending points are connected, then it's a clear indication that these elements are in parallel. Okay, so let's see a small circuit. If I say I have a battery of 5 volts, and suppose I have two resistors, and we have a key which is like a switch, and suppose I have the resistors as 2 ohms and the second resistor as 3 ohms. Okay, how are these two in series or parallel? It is parallel because, as mentioned, these two starting points are connected, at the same time these two ending points are connected. Okay, so in parallel what you have to notice is current will be different, whereas voltage will be same. So this is exactly opposite with respect to the series connection, which we discussed last 2 weeks back. In series connection the current will be same, but the voltage will be different, whereas in parallel connection current will be different and voltage will be same. Okay, so let's find it out how to find the effective resistance of a parallel connection. The formula is simple. It is 1 by R effective is equal to 1 by R1 plus 1 by R2. Whereas in series connection I had told you that R effective is equal to 1 by R1 plus 1 by R2. Sorry, R effective is equal to R1 plus R2 in series. Whereas in parallel you have to just keep it as 1 by R effective is equal to 1 by R1 plus 1 by R2. Okay, so ammeter, Highsmith. So ammeter and voltmeter are the instruments which we use to calculate voltage and current, but in this circuit it's not mandatory that ammeter should be there, but if you want I will keep it. So ammeter is nothing but it's an instrument which measures current, so I will keep it in series connection. So here I can keep as ammeter. If you want voltmeter, I also keep, and I can keep it parallel to the connection. Okay, hope you got your question clarified. Ammeter and voltmeter are the instruments which we use. Ammeter is to measure current, whereas voltmeter is to measure voltage. So it's not mandatory that you have to use it, but if it is you want to measure any parameter, then it is required. Okay, so let's continue with our topic. So in this question I'm going to find out what is R effective. So R effective is, and I will also explain why I'm keeping ammeter in series, because we have to measure any current we have to keep it in series, then only this parameter current will go to this ammeter. Whereas why we keep voltage in parallel, because voltage is always measured across an element, whereas current is measured through the element. Is this question important for question? Okay, this circuit connection is a basic circuit, but I will explain. I'm going to cover other numericals. Those numericals are important. Definitely such type numericals will definitely come for your exam. This I don't think can occur, but if it is only for 2 marks question. Whereas for the other numericals which are going to explain, those will definitely come for exam. Okay, so let's continue again. So here it will be R effective will be 1 by 2 plus 1 by 3. So 1 by R is equal to, if I take LCM, it will be 3 plus 2, which is 5 by 6. So R effective for this circuit will become 6 by 5 ohms. Okay, so let's move to the next numerical. So this is the example question which is there in the textbook. So first I am going to explain the example questions, and then in text questions, and then the exercise questions. And if you clearly understand these all the numericals, then definitely any question which is respect to parallel connection, you should be able to solve it. Okay, so in this circuit, if you notice, we have a series of cells, we have a key, we have ammeter here. As I mentioned, ammeter is always connected in series, and we have voltmeter which is connected across the elements, and we have 3 resistors. Let's see the question. They're saying that suppose R1 is 5, R2 is 10, R3 is 30. Okay, let's mark it down. I will change the color. R1 is 5, R2 is 10, R3 is 30 ohms. And what is the cell? Battery is 12 volts. Okay, I will keep the battery as 12 volts. What they are asking in the question, calculate the current passing through each resistor. Okay, and the total current in the circuit and total circuit resistance. Okay, so current across these 3 elements. So they are saying I want I1, I want I2, and I want I3. That is current across 3 elements. They are asking IR1, IR2, and IR3. Okay, so the Ohm's law which I have explained, Ohm's law is V is proportional to I, which is V is equal to Ri or IR. Okay, so now I am going to find, using this formula I am going to find the current current passing through these 3 elements. Okay, so IR1 is equal to voltage is 12 by resistance R1 is 5. So IR1 is 12 by 5, which is 2.4 amperes. IR2 is 12 by R2 is 10, which is 12 by 10 is 1.2 amperes. And we have IR3, I'll write it here. IR3 is equal to 12 by 30, so which is 4 by 3/4, 3/10, which is 0.4 amperes. So the total current through the circuit, I total, will be equal to IR1 plus IR2 plus IR3. So why we need to add all three? Because if you notice here, this I is getting divided into three elements. This I will come here and it is getting distributed across three elements, and again it is combining back. So I is simply nothing but I1 plus I2 plus I3, which is also called as Kirchhoff's current law. When one element, when the current is passing through one element, it is getting distributed, then this current will be equal to the sum of all three circuit currents. Okay, so here the total current will be 2.4 plus 1.2 plus 0.4, which is 3.6 plus 0.4, which is 4 amperes. So the total current through the circuit is 4 amperes. So second is done. They are also asking total circuit resistance. So the effective resistance are simply asking, and you have three resistance in parallel. So simply 1 by R effective formula I can use, which is 1 by R effective is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So what are the resistors? 5, 10 and 30. So 1 by R total is equal to 1 by 5 plus 1 by 10 plus 1 by 30. So if I take an LCM of 30, I will get 5 6 are 30, 10 3 are 30, and 1 is, which is 10 by 30. So I got 1 by R total is 1 by 3. So R total will be equal to 3 ohms. You can also verify whether our current calculation is correct or wrong, but simply because R total is 3 ohms, V total is 12 ohms. So I total, if I use Ohm's law directly, I will get V by total resistance 3, which is 4 amperes. So the same value I got here while calculating total current, which is 4 amperes. So hence our calculation is correct. Okay, so let's move to the next numerical. Okay, figure 10.12 I have mentioned here. So in this question they have mentioned R1 10, R2 40, R1 10, R2 40, 30, 20, 60. $30, $20 and $60. Okay. And what is the battery they have provided? Battery is 12 volts. Just a minute. Okay, so let's see the question, what they are asking. They're saying calculate the total resistance. So simply they are asking the total resistance. Okay, so before finding total resistance, if you notice, here we have two resistors in parallel and here three resistors in parallel, and if you combine these two circuit, it will be like this resistance in series with this resistance. Okay, so let's find out this effective resistance first. So this circuit I can replace as, it will be something like this. 12 volts, R1 effective, this is ammeter, so this is only used to find the current, and we have second effective resistance here. Okay, so let's find out R1 effective, R2 effective, and then simply these two will be series later, then series resistance is simple, which is R1 plus R2. Okay, so let's find R1 effective first. R1 effective, here it is 10 and 40 are in parallel, so R1 effective, 1 by R1 effective is equal to 1 by 10 plus 1 by 40. So if I take LCM, it becomes, we'll write it next slide, 1 by R1 effective is equal to 40 plus 10. Okay, let's keep it as 40 as LCM, that becomes 4 plus 1. 4 plus 1 by 40. So which is 1 by R is equal to 4 plus 1 is 5 by 40. So R is equal to 5 8 so 40, so which is 8 ohms. So I got here R1 effective as 8 ohms. Similar, let's find R2 effective 20 30 60. Okay, 1 by R2 effective is equal to 1 by 20 1 by 20 plus 1 by 30 plus 1 by 60. So LCM, if I take 60, then R2 effective will be 60, 23s are 60, 32s are 60, and this is 1, which is 6 by 60, which is 1 by 10. So R2 effective, I can say the value as 10 ohms. So I got R2 effective as 10 ohms. So what will be the total resistance? It will be a summation of these two because it is in series. So I will write the next circuit. So the new circuit will be, so the new circuit is something like this. Twelve, 8 and 10. So these two are in series. So series is simple, which is R effective is equal to R1 plus R2. So the R total of for this whole circuit is 8 plus 10, which is 8 plus 10 or 8 plus, yeah, 8 plus 10. 18 ohms is the R total. Okay, so what else they are asking in the question? Total resistance we have found it out, and total current they are asking. So simply total current will be, using Ohm's law, it will be voltage by total resistance. Voltage is 12, resistance is 18, so which is 12 by 18. Two 6 are 2 9s are, again 3 2s are 3 3s, so which is 0.67 amperes. Yeah, hi Rojalyn. Okay, so hope you're finding this video helpful. So let's continue with the next question. Rojalyn Patnaik. I'm sorry if I'm spelling your name wrong. So the question is, just the equivalent resistance when the following are connected in parallel: 1 ohm, 10 power 6 ohms, 1 ohms, 10 power 3 ohms, and 10 power 6 ohms. Okay, all together, 3 and together. Okay, the first one is connected in parallel. We have two resistors, one, and the second one is 10 power 6. So again the same formula, 1 by R1 plus 1 by R2. So this will be 1 by 1. So 1 by R effective is equal to 1 by 1 plus 1 by 10 power 6. So if I take LCM, this becomes 10 power 6 plus 1 by 10 power 6. So 10 power 6 plus 1, I can say it is almost equal to 10 power 6. So I will simply write it will be 10 power 6 by 10 power 6. So this answer is nothing but 1. So R effective, I can say it is almost equal to 1. Okay, second one, 1, 10 power 3 and 10 power 6. Okay. Three resistors in parallel. One, 10 power 3, 10 power 6. So again same formula, 1 by R is equal to 1 by 1 plus 1 by 10 power 3 plus 1 by 10 power 6. So again the LCM is same, which is the highest, which is 10 power 6. So this will be 10 power 6 plus 10 power 3 plus 1. Okay, so this value will be 10 power 6 is 6 zeros, and this will be 3 zeros. So simply I'll say 1, 2, 3, and then again 1, 2, 3, and again 1 by 10 power 6. So this value also, if I find it out, it will be almost equal to again 1. Okay, let's move to the next question. So an electric lamp of resistance they have provided. Lamp resistance is 100 ohm. R lamp, I will write and keep it as 100 ohm. A toaster of resistance, R toaster is 50 ohms, and water filter of resistance. Okay, we have 3. Another one, which is our water filter of 500 ohms, are connected in parallel. All 3 connected in parallel. Okay, what is the resistance of electric iron connected to the same source that takes as much current as all 3 appliances? What is the current through it? Okay, so we are going to find resistance of electric iron connected. Okay, source we don't have. Okay, source we have. Sorry, V source is 220 volts. Okay, what is the resistance of an electric iron connected to the same source when it takes as much as current as all 3 appliances? So we need to first find the current value for these 3 resistors, and then we need to find the current, same current flowing through this circuit. Okay. So we have a circuit which is source is 220 volts, and we have 3 appliances, and we'll simply write the resistors values, which are 100, 50 and 500. 100, second is 50, and third is 500. So we have 3 resistors in parallel. So let's find the effective resistance and also find the current passing from the source. Okay, so again the same formula for parallel, which is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So let's use the same formula again. So 1 by R is equal to 1 by 100 plus 1 by 50 plus 1 by 500. So 500 is LCM. So 1 by R will become 5 plus 50 tenths plus 1 by 500. So R value is 500 by 16. So if I divide by 2, I'll get 250 by 8. Again divide by 2, 125 by 4 ohms. So this is R effective. But we need to find not R effective, we need to find the current. So current value is I is equal to V by R. Voltage is 220. R we got it as 125 by 4. So always if you are doing this type of questions, better to keep in the fraction, because it will be easy to calculate, okay, instead of decimals. So if I divide by 5, 525 is 125, and this will be 5 110. Okay, so no other calculations. It will be 440 by 25. So divided by 5, 5 5s 5 8s are 40, 5 8s are 40. So the total current will be 5 1s 5, 38, 5 7s 35, 30, 5 6 are 30. This will be the total current. So this current they are saying is passing through an appliance which is electric iron. Okay, so simple. The current is nothing but which is 17.6 amperes. Let's move to the next question. What are the advantages of connecting electric devices in parallel with the battery instead of connecting them in series? Okay, this is very interesting question, and I'm sure everyone should know this concept, why we need to go connect in parallel and why we need to connect in series. So what happens? So okay, I will write both the circuits now. I'll keep one circuit where we have two resistors in series. You can say this is voltage and this is R1, this is R2. The same way I have two resistors which are connected in parallel. So those consider that as resistors, consider that as a devices like electric iron, electric fan, or even geyser. So those are the devices here. It's not like proper only simple resistors, these are device resistors. Okay, so for example, well, you might have seen that sometimes any circuit can go trip or some malfunction of the devices can happen. Suppose this resistors, I mean this device is having some malfunction, and due to which what is happening, the circuit is getting blocked or this is not functioning. So what will happen? This circuit will become an open circuit. So because of this issue, what will happen? This resistor also will not get current through it because it is getting stopped here itself. So the same malfunction, suppose if happens at this point, but still the current will flow through R2 without any change. It can get high currents, I can agree, but still the circuit will get the current. It's not like it will not get any current, but here the current is not even getting. It's the same way. For example, in your home you might have seen serial lights. They call it a serial lights, like when we have multiple bulbs connected to a single wire and we use it for any functions or decorations. So you might have seen sometimes that one or two bulbs might be not glowing, but still the other bulbs will be glowing. Why? Because they are connected in parallel. Okay, so this is the main advantage of connecting in parallel, is if any device gets malfunctioned, other devices will still work. So it's a simple definition. If for 1 mark, you can simply say if two devices are connected in parallel and if one is getting malfunction, the other will still work. Whereas in series connection, if one is down, all the devices will not get any current. Okay, let's move to the next question. So this is also important, and this type will be coming for your exams for sure. Okay, so let's see what is the question. How can three resistance of resistors 2, 3 and 6 ohms be connected to get total resistance 4 and 1 ohm? Okay, we have three resistors with us, which is 2 ohms, 3 ohms and 6 ohms. Okay, so what they are asking, do any combination to get that effective resistance as 4 and effective resistance as 1. Let's see how to get 4 and 1, because if it is not like single series, because if you add all three, that will be series connection, which will be 6 plus 3 9, 9 plus 2 is 11. So our series total, it will be 2 plus 3 plus 6, which is 11 ohms, which you don't want in our case because we want 4 ohms and 1 ohms. Okay, so definitely it should be 2 can be in parallel or 3 can be in parallel, then you will get the low resistance, because always remember, for highest resistance you have to keep all in series, for lowest resistance you have to keep all in parallel, but it's not like least or maximum. Okay, let's see for all in parallel what will happen. Two, 3, 6. So 1 by R effect, I'll keep it in the next slide. So 1 by R parallel all three in parallel. I'm talking about 1 by 2 plus 1 by 3 plus 1 by 6. So resistance will be 6, which will be 3 plus 2 plus 1, which is again 6. 6 by 6 is 1. So we got one connection. To get R as 1 ohm, I need to connect all in parallel. So it should be something like this. Two, 3 and 6 ohms. Okay, but if I have one more question, we need to get 4 ohms as well. So how to get 4 ohms? Let's see. So it can be either 3 cases. So like 2 can be in series with other 2 parallel, 3 can be in series with other 2 parallel, or 6 can be in series with other 2 parallel. So we'll see those 3 combinations. 2 with, so I'll keep all 3 combinations. Okay, 2 with 3 6, 3 with 2 6, or 6 with 2 3. Okay, we'll see one by one. So any one should have the connection as 4 ohms. So if 3 and 6 are in parallel, so it will be 2 plus 3 and 6 parallel. I will simply write in reverse directly R1 R2, that is 3 into 6 by R1 plus R2. Okay, what about here? It will be 3 plus 2 into 6 by 2 plus 6, and this will be 6 plus 2 into 3 by 2 plus 3. Okay, so here it will be 2 plus 6 3s are 18 by 9, so which is 2. Hence I got the answer as 4 ohms here. So this is the correct answer. So 2 ohms in series with parallel combination of 3 and 6. Okay, but still we'll see what are the other answers. It will be 3 plus 6 2s are 12 by 8. So 4 2s, 4 3s. So we are getting 3 plus 3.5, which is 4.5 here. So in the same question, if they ask you get me 4.5 resistance, then this should be the right answer. Same way here it will be 6 by 5, which will be 1.2. So it is 7.2 ohms if you want, then this should be the combination. Okay, so let's move to the next question. Find the highest and lowest total resistance. The answer is simple. The highest, all are in series. So which is nothing but all in addition, which is 4 plus 8 plus 12 plus 24, 20, and this is 28. 20 plus 28 is 48 ohms. Lowest, all should be in parallel. Okay, so let's find out all in parallel. So what are the resistors? 4, 8, 12 and 24. 4, 8, 12, 24. Okay, so let's take 24 as an LCM. I'll get 4 6 are 24, 8 3s are 24, 12 2s are 24, and this is 1. 6 plus 3 9, 10 11, 12 by 24. So R effective is nothing but 2 ohms. So the least is 2 ohms, whereas the highest is 48 ohms. Okay, let's move to the next one. So this is exercise question we are solving now. They're saying how many 176 resistors in parallel are required to carry 5 amperes on 220 voltage load. Okay, so one more trick to solve. If same resistors are connected in parallel, okay, I will tell you the trick first. If same resistors are connected in parallel, if I say like one R1 R2 R1 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 3 times, then simply R effective will be R1 by 3. Okay, so if same resistor, if it is multiple resistor, then this trick will not work. Okay, so if same resistor connected in parallel, then simply it is R effective is R1 by N. N is the number of resistors. So in this case 1626 resistors, N value they are simply asking, and identified voltage I have mentioned. So simply I will use voltage is equal to I into R. Voltage is 220. Current they have mentioned 5. Effective resistance that I told you, if it is in parallel, 176 by N. Okay, so 5 ones, 5 4 ja 40, 5 4 ja 40, so 4 11s, 4 4 ja 16, 4 4 ja 16, 11 ones, 11 fours. So simply N value is 4 resistors. So we need 4 resistors of 176 in parallel to allow carry current of 5 amperes. Okay, so let's move to the next question. So how would you connect the 3 resistors, each of resistors 6, so that the combination has a resistance of 9 and 4 ohms? So we have 2 resistors, 9 and 4 ohms. We need to get the resistance as 6 ohms. So that you will connect 3 resistors, each of resistors 6 ohms. I'm sorry. The question is, we have 3 resistors, each of resistance 6 ohms. We have 6 ohms, and 6 ohms. We have 3 resistors which are 6 ohms, 6 ohms, 6 ohms. So what is the question? We need to get So let's continue the question. Has a combination we need to get 9 ohms and 4 ohms. So if it is all total in series, then we'll get 18 ohms. So we should not use all total in series. Let's take about all in parallel. What will happen? Our parallel is 6, 6 and 6 ohms in parallel. So I told you the trick. If all 3 in parallel, that's the answer. It will be 6 by total resistors, which is 3. So our parallel combination is 2 ohms. So this is also not possible. So definitely it should be in series and parallel combinations. Okay, let's see how to get those 9 and 4 ohms. Or how about if one is in series, six ohms is in series with the other two resistors, which are 6 and 6 in parallel. 6 and 6 in parallel, I told you it is simple. It is 6 by 2, which is 3 ohms. So now this 6 and this 3 will give a combination of 9 ohms. So one is done 9 ohms, but we also want another one which is 4 ohms. All 3 in parallel also we cannot get 6. We have 3 resistors, each of resistance 6, combination has resistance 9 and 4. 9 is simple. If we have in this way, we'll get 9. 2. See the question again. 3 resistors, each of resistance 6 ohms, so that the combination has resistance of 9 ohms is possible. Only 3 resistors, we should get 4. 9 is okay. All 3 in parallel. 6 by 3 will get 2. So 4 ohms, I don't think it is possible, because let's take for other criteria how to connect. We can connect all three in series, it will be 18. All three in parallel, we already tried, we'll get 2 ohms only. Let me check, just give me a minute. Okay, we have one more connection. Sorry, it can be 2 in series with a parallel combination of third one. Okay, so let's see this combination, it will be 6, 6 and 6. So this will get 12 in parallel with 6. So definitely it will be R effective will be 1 by 6 plus 1 by 12. So it will be 2 plus 1 by 12. So 3 by 12, which is 4 ohms. Okay, so this is one connection and the other one is this connection. So using these two, we'll get 9 and 4 ohms. Okay, let's move to the next question. A hot plate of an electric oven connected to 220 volts has two resistor coils A and B, each of 24 resistance, which may be used separately in series or in parallel. What are the currents in the three cases? So let's say the first case, you have a voltage of how much? 220 volts. Used separately. So first case, it is just 24 ohms. So here in this case the current value is 220 by 24, which will 46, 455. I'll keep it as it is, 55 by 6 ohms. Case 2, series connection. So here we have voltage again 220, series connection, so it will be 24 and 24. So here the current value will be 220 volts by resistance in series connection will be R1 plus R2, which is 24 plus 24, which is 48. Okay, so simply I will say the value is 56, 55 by 12. Six 8 55 by 8 amperes. In the parallel combination also I'll write it. For the parallel combination, the same resistors, 220 volts. We have two resistors which are 24 and 24. And as I told you the trick, if the same resistor values are connected in parallel, then how many resistors are connected, those minutes you have to divide it. So in this case, the current value will be 220 by 24 by 2, which is 12. Okay, so divided by just a minute. Okay, here it should be 12. So here it is 2 6 are 12, 2 1 tenths, again 2 3s are 6, 2 55. So this value of current is 55 by 3 amperes. Okay, let's move to one more. So this is the last question for this video. So if you have any doubts with respect to the questions which I discussed in this video or in the previous videos, kindly mention in the comment section. I will definitely check my comment section. If anything is needed from my end, I will definitely check and prepare a new video accordingly. Okay, let's solve the last question for today. Compare the power used in the 2 ohms resistors in each of the following circuits. 6 volts battery in series with 2 resistors. Okay, case 1, we have a 6 volts battery which is having series connection of 1 and 2 ohms. We have 1, we have 2. Okay, we need to find the power. So before that, I will tell you the power formula for resistor. I always suggest to use I square R formula. Okay, so just find the current passing through the resistor and the square of it into the resistance will give you the power formula. We have two more formulas, which is voltage into resistance and V square by R, but I suggest you to use I square R to find the power for 2 ohms resistors. Okay, not only for 2 ohms, for any resistors this is the best formula, because if you find the exact current passing through the resistor and if you square of it, definitely get the right answer. Okay, let's find out the current first. 6 volts battery in series with 2 ohms resistors. Okay, so we need to get the current first. I told you this formula is used when current through this is the same resistor, not the different resistor or the circuit current. It is the current passing through that resistor. Okay, so in this case the effective resistance R effective is 3 ohms. So the current will be V by R 6 by 3, which is 2 amperes. So this 2 amperes will be flowing through this resistance as well as this resistance, because these two are in series. So in this case the power to 2 amperes is very simple, which is I square R. As I told you, I will use the same formula. So power across or power by the 2 ohms resistor is I square R, so which is 2 square into R value is again 2 ohms, so which is 4 into 2, which is 8 watt. Always remember the unit of power is watt. Okay, let's solve the second one. Here we have a 4 volts battery and parallel with 12 and 2. We have a 4 volts battery and we have a division like this, 12 and 2. Have a 12 volts and 2 volts and the rest 2 ohms, and the power voltage is 4 volts. Okay, so let's find out the currents passing through both the circuits and both the resistors. Okay, so this current will get divided into these two currents. I want this current. So simple, the voltage we know across a parallel connection is how much? 4. So simply current through 2 ohms, I can say it is 4 volts by 2 ohms, which is 2 amperes. Now I know the current, I know the resistor. The same formula will again use, which is I square R, which is 2 amperes. So it is the same formula, 2 square into 2, which will be 4 2s is 8 watt. So we got the same answer. Okay, but still if you want to use other formulas, how to apply in those cases? So now we cannot use simply V square. Okay, in this case V square by R also will be the same answer. So V square by R, because voltage across the 2 ohms I know, which is 4. Excuse me. So if I use V square also, I'll get the same answer. Voltage across the 2 ohms is 4. So it is 4 square by R is 2. 4 square is 16 by 2, which is again 8 watt. But here the current is not the circuit current, it is the current passing through the resistor. Same way here the voltage is passing across the resistor. In the parallel combination the voltage will be same, so it is the voltage is 4 ohms, 4 volts. Thus we got the same answer. Okay, but don't find the total current and then apply this formula. Okay, always find the current passing through the resistor and then apply this formula. Okay, so in this way most of the numericals, exercise question numericals, in-text question numericals, and as well as example questions of parallel circuit have been covered. So thanks for watching the video, and if you have any doubts kindly mention in the comment section. I will definitely check and respond to you accordingly. And if you want any personal questions and if you want to ask related to any other topic not only discussed in the video, also kindly mention in the comment section. I'll definitely check and respond to you on this. Thank you so much.